In December 2016, Elon Musk found himself trapped in severe Los Angeles traffic. Frustrated by the gridlock, he posted online that he was going to build a boring machine and just start digging. Within weeks, a spontaneous complaint turned into an actual engineering firm. The problem is geometric. Modern cities pack high-density populations into three-dimensional skyscrapers. But when those people commute, all that volume is forced down into a flat, two-dimensional grid of surface roads. Urban planners often try to fix this by adding more lanes. However, because of induced demand, new lanes fill with drivers almost instantly. The surface is full, leaving the space beneath the city as the only available direction to expand. Traffic has simply outgrown the surface above. Now, the only logical path forward is to build beneath the city. Globally, underground construction is a $110 billion market, but building here is notoriously expensive. A single mile of a legacy subway project can cost over $1 billion. Those costs are driven by the machinery. Traditional tunnel boring machines are massive, bespoke factories. They require enormous excavated pits just to be lowered into the earth, and they typically dig at a rate of just 1/10 to 1/3 of a mile per week. For decades, this sector has been dominated by a few heavy Western incumbents, like Germany's Herrenknecht and America's Robbins. But the dominant player is the China Railway Construction Corporation. CRCC is a state-owned giant with over 330,000 employees and a yearly revenue of $160 billion. Using their own fleets of massive machines, China has constructed thousands of miles of heavy, high-speed rail and sprawling metro systems across the globe. A small, venture-backed startup is now stepping directly into a market ruled by these state-funded giants. To survive, they would have to out-engineer the world's most established infrastructure companies. The Boring Company initially used a fraction of their early $113 million in funding to purchase a used, traditional machine named Godot. They used it here, at the SpaceX headquarters in Hawthorne, to dig a 1.14-mile test tunnel. While Godot proved the concept, the team realized that off-the-shelf equipment was too slow. They brought manufacturing in-house to create their own series of custom machines, the Proofrock. Proofrock changed the engineering logic. By shrinking the tunnel diameter to just 12 feet, the company drastically reduced the amount of dirt that had to be excavated, cutting the upfront capital required for every mile. The second advantage is mining continuously. Instead of stopping to install walls, Proofrock digs and lays concrete at the same time. This pushes excavation speeds toward a target of a full mile per week. It also uses a process called porpoising. Proofrock launches directly from the surface at an angle, sliding into the earth and eliminating the need for the expensive launch shafts required by traditional machines. Finally, the machine is all electric. This removes the need for complex ventilation for diesel exhaust, allowing for remote-controlled operations and a significantly smaller crew. Together, these engineering choices cut the cost of a tunnel to roughly $10 million a mile, a 90% reduction compared to the industry standard. The first commercial test of this model opened at the Las Vegas Convention Center. This loop moves thousands of passengers an hour across the campus, using a fleet of modified Teslas. During peak events, it serves as an operational proof of concept for point-to-point underground transit. The company is also scaling for industrial use. At the Texas Gigafactory, they deployed a Proofrock to dig a cyber tunnel beneath the facility to help move trucks and logistics. These projects have transitioned the company from a startup to an operational infrastructure provider, leading to a private valuation of over $5.6 billion. The company has even introduced environmental workarounds, like converting excavated dirt into low-cost boring bricks to be used as construction material. However, many of the company's most ambitious proposals have stalled. Projects intended for Los Angeles, Chicago, and the East Coast have been abandoned or quietly removed from the company's plans. This chart highlights the main criticism from urban planners. While a subway train can move tens of thousands of people an hour, a loop is limited by the space between individual cars. Critics argue this model is simply cars in a tunnel. This represents a divide between two visions of transit, a privatized model centered on individual vehicles versus high-capacity public infrastructure. While the Boring Company builds micro-transit tunnels in Nevada, state-funded rail systems in Asia and Europe continue to expand their massive, high-capacity metro lines. This has led some critics to label the venture tech theater, a distraction that promises futuristic solutions while delaying investment in proven, large-scale public transit. Regardless of how many car loops are eventually built, the technical progress made with the Prufrock machine is a matter of record. By focusing on speed, smaller tunnel diameters, and in-house manufacturing, the company has forced a stagnant $110 billion industry to reevaluate its legacy methods. If these innovations can permanently lower the cost of digging, it changes the barrier to entry for building any type of subterranean infrastructure, from water lines to traditional subways. Whether it is viewed as a transit distraction or a technical disruption, the Boring Company has successfully altered the economic expectations for the global tunneling industry.